Is up, Astro Geeks? It is your host, Aphelion, and welcome back to the show. Welcome back to the Ephemeris. Um, just said on the spot decision to call you guys Astro Geeks, and I think that'll actually kind of stick around because I think it's a cool name. We should kind of go with it. But yeah. In the last two episodes, obviously, just to recap, we have talked about the two extremes of the stellar life cycle. And today we're getting into another phenomenon that actually happens more in the regular life cycle of a star, and it is known as a Herbig Haro object. And these things are transient phenomena. They don't occur for very long, but they're still quite interesting and still intriguing to look into. So we're going to do that today. We're going to investigate into, what they generally are, the types that you can get, how they form, and what happens after they form, and kind of where, stars go from there. But yeah, let's dive straight into it, because we're not here to waste anybody's time. So, in the simplest terms, a Herbig Haro object is a byproduct of a star, and it's kind of like a brightness that occurs around a star when jets of gas interact with surrounding dust clouds. So, just to make this very clear, they're not stars, but they're kind of attached to stars. They're kind of just something that's associated with it, which is a better word to use there. The lifespan of a Herbig Haro object is a couple thousand years, because after the star becomes a main sequence, there are a couple of things that happen that won't allow them to exist, which we'll get into the after they form part. But yeah, so let's get into how they actually form. So as a star gets dense due to the gravitational collapse that happens for it to form, in star-forming regions like, molecular clouds, stellar nurseries, and starburst galaxies, to name a few, it gets bright. And there's also just a quick characteristic that is worth clarifying. It's in hydrostatic equilibrium, and basically what that means is a star experiences both upward and downward pressures as, kind of, which is kind of intuitive, but obviously star experiences upward and downward pressures. And so at hydrostatic equilibrium, those are both balanced, and so there's no change in pressure with the star. But yeah, that's just something that's integral to having an actual protostar. Two important characteristics about Herbig Haro objects are that they have a bipolar flow of ionized matter, and that we're not completely sure about why that happens. There's just a couple of things that need clarification, but what we do know is that it has something to do with just this kind of protoplanetary disk that exists around a star, which is basically just an accretion disk of gas and dust, and how that thing interacts with the surrounding magnetic field of the star. So that's kind of how the jets form, and that's a really, really important characteristic about Herbig Haro objects. And so when these jets interact with the stellar surroundings, which the astronomical term for that would be interstellar medium, they form Herbig Haro objects. So these things are just imagine them as bright patches of kind of clouds that exist around a star. I feel like that's just the best way to imagine it, because when you look at photos, you just see kind of this really bright area of the picture that's surrounded by just clouds of gas and dust, which is pretty much what I've explained so far, and hopefully that makes sense. So there are four types of Herbig Haro objects. The first one is a class 0, as they call it, and these things are very young stars, so they're not actually quite protostars, which is why we call them very young in terms of Herbig Haro objects. And what fuels the stars at this point is the potential energy that's going to kind of form that gravitational collapse and the whole the whole, hydrostatic equilibrium and brightness and all of that. And because of that, molecular outflows happen instead of ionized matter, and they're really weak emissions. So that's why I was mentioning, like, there's important things about becoming a protostar, and so that's very evident in when we investigate the different types of classes. So the second type of Herbig Haro object is a class 1, and this is pretty much among all of the types of Herbig Haro objects there are. This one's like when the star that it's around is in its prime. So the luminosity is still mostly due to star formation. It's still kind of becoming a protostar, but you'll get a lot of ionized matter, and that's kind of, where you'll get the best Herbig Haro objects. So once you get into class 2, which is the third type, you get older stars. They're like T-Tauri kind of stars, which means they're moving more into the main sequence, and they're running out of accretion material. So they will have weak flows, and they will have low luminosity. And then class 3 is the last one, and that is pretty much when a star has practically nothing left in the tank. You can barely even say it has like a protoplanetary disk, and the flows are even weaker than class 2. So what happens after they form? And this is kind of something that'll maybe illustrate what happens when a star goes from class 1 to class 3 almost. Basically, these bright patches of luminosity that we called Herbig Haro objects will move away from a protostar. And a way I like to imagine this is like if you were to breathe, if you were to exhale on a cold day, you'd have a really, really small tunnel, which the air passes through, and the fog kind of represents where that air moves. And what you'll notice when you breathe on a cold day or exhale is that it'll start out as almost like a bipolar jet, which you would see in a Herbig Haro object, but after they form, they just tend to kind of dim and disperse. So you'll see your breath get fainter and fainter as it gets farther away from you. And that's kind of the situation that's going on with Herbig Haro objects. They'll, when a star is young and it's got a lot of matter and there's jets coming out of it, there's, crazy bright patches of luminosity, but as it gets older, it kind of dims and disperses. But there are also some times where new patches of luminosity will form. So the breath on a cold day analogy is not like the best analogy, because there are special cases when it's not like that. But yeah, that's basically the gist of what happens when a Herbig Haro object forms, and what happens after. Sometimes it can be disturbed by star pulsation and such, so like something to do with the star, basically. And obviously, because of the processes that I've just described, they become less dense. Another important thing to note is that a change in the star's axis, which is called axial precession, will kind of affect, how a Herbig Haro will dim and disperse, or rather brighten. So yeah, that is what happens after they form. And just, kind of a interesting fact to leave off with is that most of the stars that host Herbig Haro objects are binary or system, which might kind of add to the understanding and make it feel more intuitive, because if you were to imagine two stars revolving around each other, or a system, then there's going to be more gas or more clouds that form around it, and there's a whole lot more that can happen with Herbig Haro objects. So that is what I've got so far for today in terms of Herbig Haro objects, and some of the kind of cool parts about it, what it is, how it forms, because these are kind of unique phenomena that happen in the universe, and I thought it was worth investigating. So that is all I have for you today. Honestly, just to give you a direction of where the next couple of episodes are going to go, we're probably going to get into some other kind of on other parts of the stellar life cycle that get interesting, like quasars in the early universe, or like pulsars and blazars, which are which really intrigue me and I think will be really worth talking about. And we're probably going to get a little bit into cosmology in the next couple of episodes, which I'm excited about because there's things like the overlooked age of astronomy, that is when some of the Eastern astronomers began to become like prevalent. And we'll probably talk about some other like important, really integral parts to what we know about cosmic theory today. And after that, I think the direction of this podcast is probably going to go towards more news stories, as I mentioned in the introduction. So I hope you guys are excited for that as much as I am. I hope you've enjoyed this episode as much as I do making it. And if you did, definitely make sure to follow the podcast and continue listening. And until the next episode, I will see you guys later.